Okay, so we know the atmosphere applies a force over an area, which we call pressure. So let's say we made a U-tube, okay, and that's what we're going to call this, U-tube. So named because it looks like a U. And we were to fill that with some sort of liquid, whether that be water or mercury or whatever it may be. If both ends of the U-tube are open to the atmosphere and are both being pushed on with the same amount of pressure, then we would expect that the levels of the liquid on both ends of the tube would be the same thing because they're both being pushed on with the same amount. Now, let's say we added to the one end, instead of having the atmosphere, we replaced it with some confined gas. And here we have our gas particles. They're bouncing around all over the place. Now, when we do that, what we now have is kind of like a push of war. We have the atmosphere pushing at one end of the tube, and we have our gas over here pushing with a different pressure. So we have the pressure of the atmosphere on this end and the pressure of our gas over here at this end. Now, there's a couple possibilities. First, if the pressure of the gas equals the pressure of the atmosphere, this is exactly where we'll stay. Both the gas and the atmosphere, they're pushing exactly the same force, exactly the same pressure. Nothing changes about the liquid here in the center. Okay? It stays level. But let's say when we connect our gas, this happens. Okay? Now we got a little bit of a difference. Now the levels aren't the same. We still have the gas pushing down on this side, okay? And we still have the atmosphere pushing down on this side, but now they're not pushing with the same force. In this case, we can see that the liquid has been shoved up towards the atmosphere, and what that tells us is that the pressure of the gas is greater than the pressure of the atmosphere. So if I wanted to figure out what the pressure of my gas was, I could measure the difference between these two heights. Right? There'd be some difference here. We'll call it delta H. Okay? Some difference, delta H, between the level of liquid over here and the level of liquid over here. Now, if we do this in mercury, so if this black stuff here is mercury, this delta H will have a unit of millimeters of mercury. And so let's say we find that our delta H here is 30 millimeters of mercury. And we know that our gas is pressing with 760 millimeters of mercury pressure that we may have measured using a barometer. Well, because the pressure of our gas is more than the pressure of the atmosphere, we know that the pressure of the gas has to be greater than 760 millimeters of mercury. The question is how much? Well, our device here tells us that. It tells us that the gas is pushing with 30 more millimeters of mercury. So I'm going to add that 30 to 760 millimeters of mercury to get an overall pressure of 790 millimeters of mercury. Again, because I can see here that the gas is pushing harder than the atmosphere, the pressure of my gas has to be higher by the difference in the levels of the mercury in the two arms. Okay? Now, the converse could have happened. Instead of it being greater than, we could have gotten something that looked a little bit more like this. Now, again, we still have our gas over here. It's still pushing down, but we can see that the mercury has been pushed over towards the gas. That tells me that the pressure of the gas is less than the pressure of the atmosphere in this case. Okay? Again, we could measure the height difference here. delta H. And let's say again that we figure out that the difference is 30 millimeters of mercury. Now this time, the gas is lower than the atmosphere. So instead of adding that 30 to the pressure of the atmosphere, which is still 760 millimeters of mercury, I'm going to subtract the two. 760 millimeters of mercury minus 30 tells me that my pressure is 730 millimeters of mercury. Again, the pressure of my gas is less, and I see that because the mercury is being pushed by the atmosphere up towards the gas. The device that we're looking at here, this U-tube, when we connect our gas to the U-tube, is what we refer to as a manometer. Okay? Again, we're measuring, or we're seeing how the pushing compares of this gas to the atmosphere. Again, the gas is pushing down that way. Here, the pressure of the gas equals the pressure of the atmosphere. So since the pressure of the atmosphere is 760, the pressure of our gas is 760. Here, the pressure of our gas is less than the pressure of the atmosphere, and I can see that because the mercury is being pushed towards the gas. So I subtract the difference in heights from the pressure of the atmosphere. And here, the pressure of our gas is greater than the pressure of the atmosphere because the mercury is being pushed towards the atmosphere. Again, because the pressure of the gas is greater, I add the pressure difference to the pressure of the atmosphere to get the pressure of the gas.